Today we are going to perform an experiment on connecting these two solar panels in which connection? Parallel connection. Okay. So now what is the rating of the solar panel? 80 watt peak. What is the rating of the solar panel? 80 watt peak. So these two panels are same rated or different rated? So as per the theory what we discussed, we need to connect these two panels of same rated, and this is a recommended connection. Okay. So when you take this two solar panel, we are connecting in which connection? Parallel connection. When you connect them in parallel, you see the ratings of the panel. Okay. So what are the ratings of the panel you can have? What are the ratings of the panel you are going to have? You see this rating, you are going to get the ratings. So write down the ratings of the panel. So VM is 17.25. VM is 17.25 and IM is 4.7. VM is 17.25 and IM is 4.7. So when you connect them in parallel, what is added? Current is added. So what is the current you are going to get? 4.7 plus 4.7. Add the current. 4.7 plus 4.7. How much? 9.4 and is multiplied with the voltage. What is the voltage you are going to get? 17.25. So ultimately I can say that this is 80 and this is 80. Total is how much? 80 plus 80, 160 watts we are generating now. So you are getting two terminals of the one solar panel. One is positive, one is negative, and this is one is positive, one this is negative. Parallel means how to connect both positives one terminal, both negatives one terminal. So we got the diagram here. And now how to connect them? Okay, so we can see the circuit diagram. So we are having one solar panel like this and one solar panel like this. So we taken the positive and we taken the positive, we joined, and we taken one negative terminal and we have taken one negative terminal. So now how many terminals are available now? One is positive, one is negative. What is the current you got? So now the current is how much? 4.7. What is the current in this branch? 4.7. So resultant current is how much? 9.4. But you can see the voltage. What is the voltage rating? So in order to measure that voltage, we are connecting voltmeter in parallel. So here I am going to connect the voltmeter, and in order to measure the current, I am going to connect an ammeter. Okay. After connecting the ammeter, I am going to connect to a variable resistance. Okay. Why this variable resistance? Why we require a variable resistor? To vary the load, to check under different loading conditions. 80 plus 80 is how much? 160. I will adjust the load as how. So 40 watts, 30 watts, 40 watts, 60 watts, 80 watts, 100, 120. For different current rate, for different loading, what will change? Current is going to change. That we are going to perform in this experiment. For different loading condition, how we are using the load at different current ratings, but voltage is constant. Okay, so you can see this diagram how we are going to get, and we have kept an rheostat. Okay, so see that the input you have taken and these are connected in parallel, and output you are getting one positive terminal and negative terminal for safety. Why? Because due to non-uniform loading, it may create some inductive effect or it may have some short circuits also. To overcome the short circuit, we kept an fuse. Okay, so this is maximum current is 5 amps. If you overload or short circuit the rheostat, this will blow off. It's like a primary protection. So if primary protection fails, you have secondary protection with MCB. So that is like automatic on and off. Okay, so if it is on, if any problem occurs, automatic this will trip off. So we enabled primary protection as well as secondary protection to protect the panels. Why? Because these panels are too costly, 10,000 and 10,000, 20,000 rupees panel. We are doing the experimentation. So now we connected to the isolator and MCB, and we are connected to the basic fuse protection. And how many terminals you got the resultant? Two terminals. Okay, so one is positive, one is negative. We connected to the voltmeter. After the voltmeter, we are connected to the ammeter. So the positive terminal we are connected to the ammeter positive, and the negative terminal we are connected to the rheostat. Okay, so this is nothing but the rheostat input, and this will act as an rheostat output, and output is once again connected to the negative. That's how we are connecting the ammeter and rheostat, and output are going to close, which forms an closed path. Now for your better understanding whether these meters are showing something else, whether really I am getting the power or not, that's why I kept parallelly a rheostat. So here we have the rheostat is connected in parallel to the circuit. I connected a bulb to make you more practical in such a way that you can understand from the solar panel what is generated, power is generated, and bulb I'm going to have an 20 watts rated. The voltage rating is how much? 12 volt system. You see here, this is system. Yes or no? So that is also voltage 17. When you see PM is how much? 17. And load is the PM value. This is a 12 and 12. What is the rating of this total plant? The experimental part. This voltage is in you can system should be 100 volt. This load is of 20 watt. What is the system voltage? 12 volts. So you can select a load up to 180 watts, but the system voltage is 12 volts. In this have different rating. Rating is different, but system voltage should be 2 volts, 4 volts, 48 volts. Similarly, in your college buses and all the traction systems, what is the rating of your college bus? 24 system. You can see 2 batteries connected in series connection. The complete bus is made up of how much system? 24 system. But this experimental part we are doing 12 volt system. Because street lights, what we do, the solar street lights are of only 12 volt system. See, I think the connections are clear from this. Are you able to understand? We are putting the panel in parallel connection, connecting an voltmeter. Output of the voltmeter, we are going to connect an ammeter to measure current. Output of the ammeter, we are going to connect an rheostat, variable rheostat, and the output we are going to close with the negative, which forms closed path. Really, to verify whether it is working, we connected an lamp. Okay, so now what we are going to do, we are going to turn on the light. You see here, nothing, there is no electrical power, but what you can see here, the lamp is glowing. Then what you understood, that really the kits are working and everything is fine. Now we converted that by using photovoltaic. We convert this energy into DC. The DC form connected a voltmeter. We calculated what is the VM value, 17 volts. You can see here now 7.5, 7.6 is the VM, and it is connected in which scale? 30. So what is the VM value? Now system voltage is how much? 12. Not this is how much? 17.8 system. Now it is giving a voltage of 17.8. You can see here already it is connected now. It is connected. It is in 180 watts load directly up 40 watts. Since it is consuming 40 watts, what is your rating? What is the rating of that bulb? 24 watts equal to V into I. Yes or no? This there is no power factor. So 24 divided by how much voltage you are going to get here? 17.8, or just take it there. This is some 19 volts or 18 volts. So 24 by 18, how much? 1 point, how much? 0.489 approximately. Don't have a cashew. 0. Approximately 5 amperes. Okay, so why it is showing 5 amperes means already we are given the input and we are trying to load in the maximum. So we have kept the rheostat in which position? Maximum resistance. This is 40. Okay, in 180 how much is consumed? 40 is consumed. 180 minus 40 is how much? 140. So from this input to this output, this is acting like how much amount of watts? 140 watts load. Which volt system? 12 volt system. It is nothing but showing 17, but this is generally considered as a 12 volt system under loaded condition. You see here, slowly I am going to vary the resistance. As you can see here, the light also will become dull and this current also will increase. Now what is the magnitude of current? 0.5. So slowly you can see here, current is increasing or not, and you can see the illumination is decreasing. Why? Because it is consuming more now. So 0.5, 0.6. So you can just write down the readings. So voltage is 17.5 into 1 and current is 0.5, I mean 0.6 into 2. 0.6 into 2 is how much? 1.2 ampere load. Okay, when the both load combined, voltage you write 17.5 0.6 into 2. Let's go and take it current into 2 and voltage 17.5. Do the, you can understand how loading is. So next current, so we are with 0. Is that not short circuit? If you short circuit, this will should be careful while doing measurement. So voltage is 17.5 and current is 0.8 into 2.6. So 1.6 you are already try to take the log 1 ampere. 1 into 2, how much? 2 ampere. Voltage is 17.5. So I am not taking it more value, but it's already loaded. You can see the bulb is giving the variations in the voltage or not. No. So this is how we are adjusting the rheostat. Sir, why you can variable stat to see the different magnitudes of current? Okay. How much load is minimum load? How much now? 0.1 into 1 ampere is there, which is consumed by rheostat, which is consumed by the bulb. Now you understand what is the experiment. Is the perfect way of putting the solar panel or not? Is a perfect way. Why? Because solar panels of same rated and current is also additive and the resultant current is applied. The current is applied. How much load we are kept here? 1 ampere load we applied. The remaining load is applied on the both. It is dividing like that. Okay. And this is how to test the solar panels connecting in which connection? Parallel connection. And how to connect the panels of same rated. You should not connect the solar panel, one is 80 watts, one is 100 watts, then which will come into the picture? If you have 80 and 100, only 80 watts only will come into the picture, remaining 20 watts you are going to lose. Why? Because it will not generate the required current. So what is the current you got? 4.7. One more will generate little bit lower current. For example, it may generate 5 ampere current. So but you have to take only how much? 4.7. There you are going to lose that current automatically. In 100 watt, 20 watts we have to lose. So that is not a recommendable connection. That's why we are connecting it. Hope the experiment is very clear. So after completing, what you have to do? You should restore the rheostat which position? Maximum resistance position. Therefore current is minimum. After current is minimum, what you have to do? You should turn off. Okay. How to start the experiment? You have to verify all the connections and you have to turn on, and defaultly so minimum load we already kept it. Slowly vary the rheostat from maximum resistance position to minimum resistance position. So now the rheostat is which position? Maximum resistance. That's why current is minimum. When you move from maximum to minimum, it's okay. So when you are moving from maximum, so this is in maximum and slowly we are moving. Automatic, what will happen? Load increases, the burden on the system increases, and this coil is getting heated up. Okay. This is how to perform an experimental part of connecting solar panels in parallel connection of same rated. We will perform it on different rated later. Okay, thank you.